Okay, let's give you guys a calculus 1 problem. So here I've got a circle of radius 1, so 1, 1. And if we look at this, a gradient of 1 would be a diagonal line like this. And if I move it across, you see right here, there's a point where the gradient will be 1. And then there's another one down here. There's another one down here. Okay, so here we've got a gradient of 1. Here we've got a gradient of 0. Here we've got a gradient of -1. And then somewhere around here, there's a gradient, a really steep gradient of, I don't know, let's say 99. So somewhere between here and here, because this has a gradient of 1, this has a gradient of 99, somewhere in between there will be a gradient of 2, precisely 2, maybe somewhere around here. So your job is to find the coordinates on the circle where the gradient is 2. Okay, so press pause and have a go, find the coordinates where the gradient will be precisely 2. There's another one down here somewhere, but let's forget about this one. I'm only interested in this one. So press pause and have a go. Okay, so to do this, let's rearrange this to make y the subject. So take away x squared, and then square root both sides. When you square root both sides, you will get the positive version and the negative version. The positive version would be this strand here. The negative version will be this strand here. I'm not interested in the negative, so let's discard the negative and just consider the positive only. So this strand here is given by y equals square root 1 minus x squared. Okay, so now we've got to differentiate it. So this strand here is given by this. So we want to differentiate it. That will then give us dy by dx, and then later on we want to know where the gradient will be 2. So we would put 2 into the dy by dx. You see what I mean later on. So first step, differentiate it. So let's imagine this as being bubble to the power of a half. So bubble to the power of a half. So when you come to differentiate it, the half will come down, the bubble stays the same, the power gets minused by 1, and then you've got to times the derivative of the bubble itself, which will be negative 2x. And then your eyes should zoom into this bit here. You can see it's a negative power, so you immediately jump to 1 over. You immediately jump to 1 over to the power of the positive version, and then to the power of a half is really the square root, which will then give you this. And then you've got your fraction here. You've got your fraction, and then you've got this bubble here. This bubble here gets multiplied to the top, and then here you've got a fraction times a fraction, so it's going to be top times top, bottom times bottom. That will then give you this. That will then give you this, because the two 2's will cancel each other out, giving you this. So dy by dx equals this. But then we want to know where the gradient will be 0. So we want to know where the gradient will be precisely 2. So we would put 2 into the gradient and then work backwards to find a value of x that will give us a gradient of 2. So put 2 into here. That will then give us this. And then now it's just a matter of finding out x. So to get x on its own, times both sides by the denominator. That will then give us this. And then from here, square both sides. So when you square this, that will then give us this. When you square this, it's really a block of 2 times a block of square root 1 minus x squared. So merge these two together, that will be 4. Merge these two together, that will then give you this. So now multiply this out. That will then give us this, and then add 5x to both, add 4x squared to both sides. That will then give us 5x squared, and then divided by 5, and then that will then, when you divide it by 5, it will take you to here. When you square root both sides, you will get the positive version and the negative version. I'm not interested in the positive version because I'm interested in the negatives. I know it's somewhere around here. I don't care about this place over here. So I'm only interested in the negative version. So that will then give us this. So x must be negative 2 over root 5. So we know that x must be negative 2 over root 5. So the coordinates here will be negative 2 over root 5 comma something. Well, if you want to know that something, which is this height here, then put this into the x, because we know the x location, square it, that will then give you this, and then this whole thing here will then become this, and then we want to know the height, which is the y value. So take away 4 over 5 from both sides, that will then give us this thing here, square root you get the positive version and the negative version. I don't care about the negative y, so I'm only interested in the positive y. So that will then give us this thing here. If you simplify this, it will then give you this. So the coordinates will be 1 over root 5. So this is your answer. Okay.